Hello and welcome to this special series System Verilog Assertion. Already I have explained the contents that we are going to cover as a part of this series. Now, this is the first video of that series. It is just an introduction to the System Verilog Assertion. So the points those I am going to cover in this particular videos are here on the screen. You can see. We'll try to see what is assertion, what are assertions, need of assertions, why it is needed, who will write the assertions, whether it is a responsibility of a design engineer or the verification engineer. Then some advantages of assertions. Then we'll see the limitations of assertions. And then at the end, we'll try to see the system Verilog assertion in the event scheduler of the system Verilog. Okay. Now the first point, that is what are assertions. So if you see the literature, you will find many definitions. So the simple one is it is a verification technique, you can say, that is embedded in the design itself. So in the design system Verilog, it is embedded to check, to do the verification of our DUT. Then assertions are the properties that must be true. So if you just analyze a simple assertion, you'll find it will have a property and end property construct in which we can write some assertions. So as you can see here, just at every passage of the clock, if there is a dollar rose, meaning 0 to 1 or 0 to anything, you can consider it as a positive edge on this dollar $A. Then assert this property at every passage clock. Find the passage in the A signal. So as you can see, we are defining the assertion inside a property and end property block. So you can consider it assertions are the properties that must be true. And the assertions are primarily used to validate the behavior of design, whether the design is working as per the specification or not. Now the second point is need of assertion, why we need to write the assertions. So first point in that is it will give the white box visibility for our black box design. So as you know, as a verification engineer, we just have the black box visibility for our DUT. So we cannot see the internal architecture of the design, right? That's why we can say as a verification engineer, we have the black box visibility of the design. And with the help of this assertion, we can get the white box visibility for that DUT or the design. So if we are getting the white box visibility for our DUT, we can detect the bugs at or near the source of the problem. And if we are finding the if you know where the bugs actually is there, we can easily debug, and we can easily and quickly debug that bug. And if we are easily debugging, if it will take less time, then the product cost, it will affect the product cost. So as you know, the product cost is directly proportional, the product duration is directly proportional to the cost. Okay, so this cost is actually duration. Okay, you can consider it as a duration. So product duration is directly proportional to the cost. Okay, now the third part is who will write the assertion. So just we have discussed that as a verification engineer, we have the black box visibility for the DUT, or you can consider for a design. So as a verification engineer, we can write the assertion for the input and output of an IP or SOC. Okay. And as a design engineer can write the assertion at the microarchitecture level. The signals, those are invisible or to the verification engineer. He can write the assertion for those signals. For the architecture levels of the design, he can write it. So it is a responsibility of both. I can say it is a responsibility of design engineer as well as the verification engineer. Okay. Now, what are the advantages of assertions? So many advantages, just we discussed, you can consider them as a advantage. First one is it will give the white box visibility for the black box design. We can find the bugs at or near the source of the problem, and we can debug them quickly. Okay. Now, can we write the assertion in Verilog? Yes, of course we can write. But the problem with Verilog assertion is that the code is lengthy. So, for example, let's take, if you want to write such kind of assertion in case of Verilog, we need to write some 8 to 9 lines of code. And every time we need to write some $display statements if the assertion is passing and failing. But in case of system Verilog assertion, the code is compact. Within some few lines of code we can get whatever we want. Then there is no need to write our own $display statements. The simulator expect to print the default message if the assertions are failing. And optionally we can define the action block so that if assertion is passing we can print a message, else we can print the other message. Now in system Verilog we can write the assertions, or we can define the assertion at outside of the DOT. But in case of Verilog, we need to write the assertion inside the DOT itself, that module and in module itself. We cannot define the assertion outside of the module. But in case of system Verilog, we can write the assertions at outside of the DOT. We can write it in separate module, and we can use the bind construct to connect the assertion to the DOT. Okay. And with this, reusability will be there for assertion. Now, what are the limitations of assertion? For assertions, first we have to define the assertions very carefully, because if we are defining incorrect assertions, it may give us the misleading results. So it is carefully we have to define the assertions. Then there is no any metric which says that the enough assertions we have written. So we cannot say that by writing this much of assertions it is enough to check or to find a bug. So if we are writing multiple assertions, then meaning it will become a burden on the simulator, and maybe the simulation can be slowed down. And the third one is like, still we need to write the test bench architecture. Inside that we have to write a test stimulus. Stimulus still we need to generate, because if if we are writing the assertions, or if we are not writing the assertion, stimulus is need to be generated. Okay. Then how the assertions are there in the event scheduler of system Verilog. So if you see over here in the diagram, you'll find there are some regions, right? Pre-pond region, active region, inactive NBA. So active, inactive NBA, where our design is DOT is working. Now, as you can see, this pre-pond region. So sampling of the assertion will happen in this pre-pond region actually. Okay. And there is an observed region in which evaluation of the assertion will happen. Okay. Now there is an reactive region in which the execution of pass or fail of the assertion we can find in this reactive region. Or if we are defining optionally action block, that will be executed in this reactive region. So these three are the main reasons in which assertions actually are working. So in first pre-pond region, sampling of the assertion will happen. Then in observed region, evaluation of the assertion will happen. And in the reactive region, we can find the pass and fail of the assertions or the action blocks if you are defining. Now the books, some books are there. If you want to do the comprehensive study, you can make use of these two books. So the books I am referring also, first is a practical guide for system Verilog assertion by Shrikant Vijay Raghavan, and another one is system Verilog assertions and functional coverage by Ashok B. Mehta. So if you want to do the comprehensive study on this system Verilog assertion, you can make use of these two books for theory as well as for some good examples. If you want to see the website, there are many websites like Verification Academy is there, you can refer them, and Chip Verify is there, verification guide is there. You can also make use of those websites to start with assertion. So with this, I hope you have understood, the introductory part of this assertion. What is assertion? Need of assertion. Why to write the assertion? Who will write the assertion? It is a responsibility of design engineer and verification engineer. Some advantages of assertion, limitation of assertion, and how the assertion is there in system Verilog eventually. And also, I hope you enjoyed this video. So thanks for watching. Thank you. So from the next video, we'll try to look at the examples of assertion. I will try to see the types of assertion, and from that video only, we will take a practical example to see the assertion. Okay. So thank you.